Okay, good afternoon, folks, and welcome to the Create Energy webinar series. My name is Ken Walls. I'm the director for the Create Center, and today's webinar is going to be on the topic of troubleshooting and safety simulation for wind turbine technician education. This is being produced by the Purdue University Center for Innovation through Visualization and Simulation. Before we begin, I'll just go through a little bit of housekeeping details, and then I'll provide an introduction for our speakers. I will say that the most common question we get is this webinar going to be recorded, and will the materials be available later for download? So let me just address that right away. If I just advance the slide here. The materials from today's webinar, you will be able to find them on the createenergy.org website. This is a screenshot of that website. If you haven't already done so, you might want to sign up for our mailing list while you're there so that you get notifications of future webinars and events. On that website, if you go under the publications tab there, you will find a list both of all our print publications as well as all of our streaming digital webinars. You can see some of them listed here from earlier this semester. Both the recording of the webinar and the presentation slides will be posted. And I would say today's webinar will probably be up there by sometime early next week if you would like to access it or to share the link with any of your colleagues. The other thing I will ask is during the presentation, if you have any questions, please feel welcome to put those in the chat window. And I'll monitor the chat window while our speakers are presenting, just so they can keep their attention focused on the task at hand. And then we'll hold the questions to the end for Q&A and discussion after the speakers are done presenting. Our presenters for today will be Jack Moreland and Kyle Toth from Purdue University Northwest's Center for Innovation through Visualization and Simulation, or CIVS. The center is a multidisciplinary research group that combines advanced simulation with 3D visualization and virtual reality for business, industry, and education. Through partnerships with more than 130 external organizations, the center makes educational and economical impacts in multiple areas. Jack Moreland is a senior research scientist at Purdue, and he has a master's and bachelor's in computer graphics technology. And he's currently completing his PhD focused on virtual reality for occupational safety. He has over 50 technical publications in the areas of interactive training, 3D visualization, and simulation. And his research interests include virtual reality, augmented reality, and 360-degree video production. Kyle Toth is a research engineer at Purdue. He also has a master's degree in electrical and computer engineering and a bachelor's in electrical engineering with a minor in applied mathematics. He has multiple conference and journal publications in the fields of data visualization, virtual learning, simulator algorithms, and interactive training. Kyle's research and interests include game development and methodologies, enterprise and consumer computing solutions, and real-world virtual reality applications. So with that, I'm going to turn things over to Jack and Kyle. I'll stop my screen share and let you guys take it away.
All right, great. Thank you, Ken. We'll go ahead and get started here. All right, and so everybody should be seeing a slide with some yellow text on it.
Mm-hmm.
Great.
Yep, we can see it. Looks good.
All right. So thanks, everybody. Thanks especially to Ken and your group for inviting us to take part in the webinar. What we're going to do, we'll start off with some background information, present some slides on the project itself, the simulator, what it does, and then turn it over to Kyle to actually give us a run-through of the software, and then we'll have some time at the end for questions and answers. So first off, just to avoid confusion, if you look up my name anywhere, it's going to be John Moreland, but I go by Jack. So feel free to call me Jack and questions and stuff like that. This is a project that was sponsored through the NSF ATE program. And we've got the award information spread throughout the slides, a couple different places. So first, a little bit of background, who we are. So we're a research center inside Purdue University Northwest. That's one of the campuses just about a half hour from Chicago. We do a lot of research specific with our title, simulation and visualization. We do a lot of projects sponsored with industry, some federally sponsored projects, but our focus is the combination of simulation and visualization technology. We have a lot of students go through our center, work on a lot of projects and have a lot of collaborators, and we're always looking for more. So we encourage people to reach out to us afterward if you see anything catches your eye and you might want to collaborate. A little bit about our methodology and how we put these things together. This is exactly what we used for the simulator we're showing today, but it applies to lots of other projects as well. We have kind of two halves of our house. So we have the simulation side, which is more mechanical engineering work, flow simulation, these sorts of things, and then the visualization and training side of our house. And so for most projects, we have overlap when we put these things together. So we'll crunch some numbers. So in the area of wind, we're doing wind flow simulations, things with wakes and maybe stresses inside the gearbox and those sorts of things. And then we'll visualize those using scientific viz methods. On the other side, we'll start with photorealistic 3D visualization. And then we'll put those together into these simulators. The simulators can run in VR, PC, mobile, other platforms. And one of the things that we tend to keep on doing is testing out new technologies as they come out. So in recent years, of course, like gaming has made VR headsets that you can just buy off Amazon or at Best Buy and stuff much more popular. And so we continue doing things in those areas as well. So a little bit about what is virtual training. Not everybody's familiar with it. Virtual reality, not everybody's tried it. In general, we can use these for a couple different uses. So maintenance, troubleshooting, operator training, safety, and there's various reasons for each of these. Benefits are you can reenact emergency scenarios. Yes, you can give people training for regular situations, but one of the strong points is you can put them in these unusual situations or uncommon situations and have them practice in a safe environment. You can teach in an engaging way. There's lots of studies saying the more engaging you make the training, the more it's going to resonate with people, the more they're going to be able to translate it into real action out in the real world. Authentic and situation-based training, and also able to put into a little bit clearer understanding for hard to explain concepts, especially things that are invisible or conceptual. Where wind is concerned, we got our start back in 2009. We were awarded a Department of Education FIPS project that introduced us to a lot of the people on this call. And so we've continued those collaborations on. We started, this first project was called Mixed Reality Simulators for Wind Energy Education. And so we developed a number of these pieces of software. Some of them were for PC, some of them were for web, some for VR, some for AR. But really the guiding thread was some aspect of it had to do with either wind turbine design, maintenance, troubleshooting. And so, whoops, that guy is not the right size. Let me back us out 1 second and fix that. That's what I get for doing a last minute tweak, apologies. All right, so what we've done over the years is we continue to assess the simulators. So we have a group of colleges that have continued to use these over the years. And so we continue to test those. And across the board, we get increase in student test scores, interest in students considering going into the wind industry. And this is both for technicians and for engineers. And in addition to these sponsored projects, this has also spawned a lot of research for master's thesis projects, undergraduate senior design projects, and the like. one other I'll draw attention. We aren't focusing on augmented reality today, but just want to touch on it. So in this bottom video, you see we have a project that we did for gearbox inspection, where we actually put together an augmented reality simulator tied in with a borescope. That way somebody can practice with the real equipment, but get the visual and the simulation aspect of it, so you can simulate scenarios of different things you might encounter in gearbox inspection. I also want to mention, in addition to federally sponsored projects that produce a lot of these software, we also do a number of collaborations with companies. One of the more recent ones that we've continued up with is in Indiana. We have the Northern Indiana Public Service Company, NIPSCO, and so they're in the midst of a push to transition a lot of their utilities to solar and wind, and so we've continued to work with them. We're very very thankful for them helping us to establish an endowed professorship, and our director for our center, Chen Zhou, has been the NIPSCO Distinguished Professor for Engineering Simulation. And a focus for any company that we pair with: workforce development, of course, training, public awareness, education, and these are things we're focusing on with the NIPSCO partnership as well. All right, so on to the project at hand. So the objectives for this current ATE project are: we want to develop this interactive 3D troubleshooting and safety simulator, teaching modules for wind technician education. This is put together by a committee. We have a group of collaborators. Some of them are on the call. We'll actually invite them to say a few words at the end of the presentation. But really, we pair up with community colleges that have courses that would benefit from the simulator. And then we really follow their lead, follow their guidance, what things are going to be useful in the classroom. As well, we have input from industry collaborators as well. And then we assess that effectiveness. So our motivations, the focus here is on troubleshooting and safety. So one of the challenges, if technicians aren't shown the right way, they tend to grasp in the dark when they're met with a problem. And so there's a better way, systematically troubleshooting and being able to find those issues and get them resolved much quicker. Safety is throughout, so there's not just a separate component for safety. This is spread throughout the simulator. And one of the things that this definitely benefits is any program where there might have limited access to wind turbines. We're aware not all wind programs are created equal. Some of them have access to as much real-world wind turbine experience as possible. Others, there may be time limitations. Sometimes there's facility limitations, but the simulator lets students have access to work in a wind turbine environment. I'm going to show a short video run through of the things that Kyle's going to go through in more depth. Key thing here, we have this software, we're showing it on PC. We have the education modules section where we have a couple different more class type information. And then we jump into the simulator itself. We teach a little bit of the basics of troubleshooting. We have some tools in there for doing electrical troubleshooting, some other things. We have a virtual SCADA system we're continuing to build out. You typically start at ground. You'll do a little bit of remote troubleshooting, and then you have to head out to the turbine, sorry. And as you go in, then you continue to troubleshoot. You have access to some schematics, and you have to identify the issue and continue to go from there. Different parts of the turbine are more fully developed, and so Kyle's going to go into more detail on some of the scenarios that are available right now, and we'll continue to build those out. In addition to the scenarios that we're building into the simulator, we're also going to be providing this interface for instructors to build your own scenarios, either customizing existing scenarios or creating new ones. And so on screen now is some of that interface for instructors to use So you're not having to start from scratch. Moving right along. And this one isn't part of the official project, but just the nature of our center and what we do, we're very interested in where virtual reality might be useful. And so this is showing a little bit of a proof of concept that we've put together using the environment from the wind turbine simulator, where you can go choose some PPE, go out to the turbine. And in this one, we're really focusing on the safety aspect, fall protection. And so just a little bit of the VR experience. There's not so much troubleshooting in this one. You can examine parts of up in the nacelle, but really it's proof of concept. But this and the simulator itself, we'll go into more detail later, but these are going to be accessible for anybody on the call to use. We want these to be out in the hands of as many people as possible. And so we'll have some information at the end of the presentation on how you can get your hands on it as well. So here we see down in the bottom right corner is yours truly in a VR headset looking around. And that's why you see me turning around. So everywhere that the user is looking, that's what we see on the big screen here. Some of the things we can leverage in VR is, you saw I use the controller, I reach behind my behind my back to grab my hook there, tie off to some location, and then just this basic functionality of if you fall and you're tied off, you stop falling. So, and then we also built in this little piece where you can rappel down a blade and do a little bit of basic blade inspection. Again, proof of concept, not built out in detail, but lots of room to continue building onto the simulator in the future. So with that, I'm going to invite Kyle to take control and walk us through the simulator itself.
Okay. Okay. I don't know, can everybody see my screen then?
Yep.
I'm sorry if it has some black letterboxing going on, but I have an unusually wide monitor. So I'll go through a little bit here. Actually, let me skip just to where Jack just left off. And I'll start from here. So essentially, let me see if I can swap these. There we go. Okay. So just to give you kind of a brief idea where I'm starting off with, I'm basically going to go through most of the simulator and most of the content that's contained within the simulator, kind of just in a step-by-step, kind of naturally as I would navigate through it if I were explaining it to anybody else for the first time. And I have some slides that are not necessarily useful for people that are watching me talk about this right now, but perhaps for people that will be looking at the slides after the fact. And they just have some important information or quick summaries of some of the longer bits of this. So, so starting out, when you open the software, you'll see a main menu like what you see here. So start, tutorial, options, and an exit button. So essentially what will happen at the beginning of these is once you're in there, the options are kind of there for people that have not so powerful computers to be able to run this. We have the ability to change some of the graphic options for the software itself. So people running on like really old laptops can still attempt to run the software, or if you're running on computers in labs that are a little bit outdated, you can still try to attempt to run the software. There's some presets that are available. You can also change them manually to suit whatever needs you have. So once you're done with all of that, there's a few other steps that you can do. You can mess around with it basically as much as you want. The tutorial exists there. I'm not going to actually have this since this is pre-recorded. The tutorial would go through a lot of what I'm going to talk about in a much more accelerated format for people that want to just plug and play with it right away. So it's going to go through the start, so that on the far left are basically buttons that you can use to check or click for different sections of the simulator. So education modules more or less cover things that are more like e-learning. So basically kind of more or less PowerPoint or videos with accompanying quizzes. The troubleshooting scenarios that are basically the virtual simulator itself, the scenario builder, which builds in some of the customizable aspects of it, which I'll get into respectively when they get there. Right there, you can see it scrolling through the About section, which is kind of an attribution of all the people that have helped put this together. And I'll go back into the scenario builder later in the actual video itself. But starting off under the troubleshooting scenarios, there are a few different things to pick. But I think it'll start off going through the education modules here. So eventually we plan to implement more modules, but so far most of the topics that we've started building in are related to safety related topics. So as Jack mentioned before, fall protection, arc flash, actual driving safety parts, and a little bit about just hazard assessment in general. So as we go, it'll get in there, and I'll fast forward a little bit so we can see what we're doing here. So essentially, once you click on the button to go into safety modules, you should be able to access this menu here. There's a short list of things that are available to pick from, and like I said, these are presented in more of an e-learning format. And essentially what happens here is you can pick from any of them. The software will actually remember which ones you complete, and that's what those checklists for are on the right side. There's multiple ways to navigate through them. It's basically presented as, you might have in an online learning management style class or something that you would submit online, but this is mostly for the user. So you have the ability to go back to like the main menu, back to the overall selection, exit the software. You can do that at any time during them. But you also have the option to take a quiz based on the subject, which I will show how that works as soon as I scroll through it a little bit here. But you can see that you can click. So that's what I'm doing there. You can use the A and D keys like you would in a PowerPoint, or you can use the left and right arrow keys like you would in a PowerPoint. So overall, you go through, it has stated learning objectives for each one, what you should learn by going through the slides that are based on a combination of different materials that we've collected from the different collaborators that we've had, plus some things we've had from other industry-related projects that are more or less OSHA requirement aligned. And so once you're done and you've looked through everything, then you kind of have the ability to take a quiz on that topic. And some of them have longer or more questions, some of them not so many questions. It depends on how much content was covered in that e-learning module. Once the user goes through each of the questions, it'll give you feedback about a score and whether or not you have passed. So if I skip ahead slightly here, we'll see that you get to pick from different options. So you can pick one of the three. So I'm pretty sure I just picked randomly across the board of which one I would choose. And then once I'm done, I'll go ahead. It'll give me the next question, and then we'll continue going through till the end, where it'll give me a breakdown of how many questions I got right versus how many I didn't. Here, the passing grade was set to a 70%. So since I scored a 75, I passed. Now it knows that I've completed the Arc Flash e-learning. And this was stored in a file on the computer in the same folder as the application. And it can be very easily deleted. It will reset all of your progress for the e-learning modules. But in general, it keeps track of which things have been passed. So following that, this gets straight into kind of the actual troubleshooting scenarios. So there is a kind of tutorial for people that have not used the software before to learn how to use the digital multimeter that exists in the software and kind of how to utilize some of the tools that you need to do the electrical troubleshooting section. So this is based off of a troubleshooting box that Tom Sutton uses to teach about a lot of the basic troubleshooting techniques at his community college program. So basically we take the user through the interactions of breaking down piece by piece what some of the components are: fuse, relay, power supply, terminal blocks, And then basically, you know, showing, okay, here's how some of this stuff interacts. It's based off of a light circuit, similar to what you would find down tower in the wind turbine. And then once you've, you know, kind of gotten to mess around with it a little bit, the step-by-step tutorial will now kind of show you, here's all the functionality that exists, and here's how all the ways to turn on and off the light work. If I skip forward a little bit here.
You're not cold wet? One little blanket?
So there's all ways to do it. So here we can actually see that the actual light switch is on a timer and all of these kind of cool things. So now, in order to actually generate troubleshooting section here, the tutorial actually, at that point, the tutorial introduces kind of an issue. So some of the values across the troubleshooting box were changed. Now we can't get the light to power. And so now, basically, it's going to take us step by step. The first thing it wants us to do is it wants us to look at the schematics. So it will have us open that. So the schematics themselves, in this case, there's only one page. Ordinarily, you would have a whole book to look through. So we start looking at where the tower light switch is, and we want to actually check to see right there. We can see in my mouse here, the wire that goes to the front end of the tower light switch, the input side of it. We trace it back to where that goes onto the terminal block, and we want to see if there's actually voltage there. And ordinarily, if there's no voltage there, then we continue checking to see where we're not getting power. So here it kind of says, okay, so now we have a targeted area. Now we're going to take a measurement. So this is going to be the introduction to the measurement. So originally, this was set to be done by a series of button pushes, but due to feedback, we've actually changed this. So now we kind of have interactable graphics for the multimeter probes. So the actual multimeter itself works on a system of, are both of the probes touching valid measurement points, essentially. And then once it's confirmed that it is touching, both of them are touching valid measurement points, it'll use the information that's being fed to it to allow us to take that measurement. So there's a pretty complex code going on behind the scenes that's basically taking a bunch of inputs from wherever those multimeter probes are touching, and then depending on those inputs, then spits out some output on our multimeter for the measurement reading. And I have a little bit that I can add on to that, kind of maybe more later into the scenario customization section. But once you've kind of gotten the idea of taking the measurement, then it will go walk you through the process of, okay, you've done that. Now you need to kind of give some sort of feedback or file some kind of report, in this case, of what you suspect the issue is, what do you think the solution for that issue would be, and how would you go about it? So this works in a way where the user can input their name, their suggested problem, and the suggested solution for that problem, which then gets saved out as a file that can then be referenced later. Some of the scenarios will actually have some already pre-recorded or pre-wired problems and solutions that are the scenario that they're using is based around, and if there is information for that, it will also be included in the output. So since this is just a tutorial, it's not just going to continue going after that. So manually, you'll have to actually leave the menu. So in case we're going to restart the software to go back to the main menu. So from there, we also have the option right there, as you can see, a button. It's basically the same troubleshooting box, but there's no specific problem there. You can just kind of mess around with it, look through the schematic for it as much as you want. You can take as many measurements with the multimeter as you want to just kind of get used to doing the interactions that the guided tutorial kind of makes you go through step by step. You can take it at your own pace that way. So outside of that, the main scenario that's built into the simulator that we usually use here is a pitch control scenario problem. So this was originally built out towards the end of the first year of the project, and it ended up being a really big rabbit hole that we went down, making sure that there was a lot of functionality and features included to be able to actually tackle a lot of the kind of subtle parts that are needed to deal with troubleshooting this type of problem. And thanks to Tom for giving some feedback on how to make the SCADA work. I actually want to take a moment here to pause the video and talk just a little bit more about this particular part. So in addition to making just the whole module for doing the troubleshooting, electrical troubleshooting and doing all of this, the actual remote troubleshooting section of this was very difficult to figure out how to implement, even for starters. So hopefully by the time that this project is completely over, what we will hope to have available is a completely kind of virtual SCADA system that's basically like a software inside of a software. It's just going to be very limited compared to what you might actually have as, you know, some kind of pro level solution for your wind farm. But as it stands right now for the current modules as we have them, I'll let the video continue playing. We have it set up so that a lot of the steps that would be taken in the virtual software for remote troubleshooting is kind of done for you. It's kind of given to you in a step-by-step format of here are the steps for the remote troubleshooting you should take, and here's what you would get for those steps. So we get an error number, we look it up in a manual, here's what the error number says, do a little bit more sleuthing about some of the things involved with that error number, and then you can find something to start from as far as what you need to do. So then once it's done and you've seen what that SCADA readout is, it actually basically prints it out into a panel that you can open at any time that you want to look at it. It should say exactly the same thing that it said in when you clicked on the computer for the remote SCADA readout stuff. So it should be exactly the same. Then we grabbed a procedure form. So this is basically going to give us kind of a step-by-step for safety, lockout, tagout things involved in the work area that we're dealing with. Some information about, you know, suggested dangerous wind speeds, what kind of equipment you might need to deal with. And then we move outside to actually grab some of our PPE. We also have a flashlight that the user always has at all times, and it can help in certain areas where it's dark all the time. So, but going through, grabbing all of the equipment, once we've gone ahead and grabbed all the equipment, some of it may not be necessary for particular scenarios. Then we can go to the truck that's in the warehouse. It'll take us out to the tower. So right now we don't actually have a physical user character that's, you know, walking around. So we kind of have a flying camera that can go to different parts of the tower. So some of the down tower parts haven't been completely fleshed out and modeled yet. But a large section of the nacelle and the hub had been where a primary bunch of the electrical troubleshooting has been kind of focused on. So we can look through our objectives again to see what we're looking at. So we know that the pitch motor brakes are going to be in the hub. So we're probably have to fly out to the hub to kind of do some investigation on what we're looking for in there. So we're going to fly out there. So now we have access in the hub to all of the axis boxes, all of the battery boxes, the center box, and the pitch motors. So we already know that the pitch motor is going to be where the issue is. So we have the options when we go to interact with the pitch motors. We can look at the schematics, or we can start taking some measurements. The schematics are available in a variety of different ways. I will take a 5-second pause here. You can actually see that there's always a persistent schematics button that can be used to bring up the schematics from anywhere. But pretty much any interactable component also has a button that you can use to access the schematics. In case, you know, for some reason that when you go to interact with that component and you want to check to make sure that that's the right component based on whatever troubleshooting, remote troubleshooting you've done through the schematics already, you can actually look through it there. It's kind of almost like a reminder. And it looks very similar, works very similar to the the troubleshooting box tutorial that I just showed you guys. So right now, in this particular case, it was very hard for us to come up with discrete measuring points in a very nice format. So a lot of the measurements that are done, particularly at the pitch motor, are kind of done through a series of text boxes. It's going to say, hey, shouldn't really be taking measurements of the pitch motor unless you're in manual mode. So it actually forces you to go over to the center box to engage manual mode, to basically calibration mode here, so that we can actually take some of these measurements. So we're going to go ahead. We're going to take some measurements across the pitch motor brake. The variable that we got from our SCADA that's in our objectives there tells us particularly that a pitch motor brake seems to potentially be an issue, so that's why we're checking that. And so now that we're able to do that, we're going to get to this third one. We're going to check voltage, and it's going to tell us that the voltage isn't what it's rated to be in a stop mode. So now what it's going to do is it's going to tell us, hey, this might indicate that there's a problem. We should also check to see what the resistance is. It's rated to be 13 ohms across the motor, but in this case, we're seeing a lot higher than 13 ohms. That's going to indicate to us that we have either some kind of break or we have some kind of corrosion that's causing some issues. So that basically means now, okay, we're going to need to replace that. We do that, that's fine. So now it's going to, give us some kind of little bubble here that's going to tell us you call in for the replacement. Now, you would need to have it installed, and you would need to recalibrate afterwards. So now that we've done that, you can just see some of the other things that I didn't do in this particular section. We have Navigateable schematics. These are based off of some educational versions of a GE 1.5. A lot of our previous wind materials were based off of different references of different GE 1.5s, so this kind of fits our particular setup a little bit here. So we don't have like all of the schematics in here at the same time, just maybe particular sections of the educational schematics that are relevant to sections that we've included as measurable areas for the electrical scenarios. So in this case, we can look through different things. We can look through the axis boxes, battery boxes, documentation for the center box, and then see how all those things are wired together in case we need to do maybe a little bit more intricate troubleshooting once we're on site. And doing that type of thing. We also have a built-in notes feature. So if there are certain things that a user wants to keep track of while they're doing this that's not related to whatever they've gotten from the SCADA, they have an option to do that inside of this notes box. And this will also be printed out to a file with the report when they file that at the end. And what that can do there is if they don't arrive to the same conclusion that whatever hardwired problem and solution is coded in for this scenario, you may be able to use their notes to find out where they kind of diverged from that and be able to figure out if they were close or they were completely off in the first place. In this particular case, it tells you once you found the problem that you have found the problem, and then kind of the very abridged version of the steps after that. But once that's all done, then you can go ahead, you can hit the file the report. It's going to let you know that the report has been filed. That means that the file has been written. And then essentially now it'll take you back to the main menu because you're done. So the next thing that it'll probably go through here is the actual scenario builder section. So now this is kind of the idea of, okay, so we have like all of that stuff that we saw in the hub that was measurable. Now, what happens if we don't want to have a pitch control issue? We want to simulate maybe some kind of bad wiring job was done during some maintenance on one of the battery boxes or something. Or some other issue that is maybe more common to your particular wind turbine farm than maybe somebody else's. And we want to try and get maybe students used to that particular issue. We have a scenario editor here, and I'll pause this for a second just so I can go through some of the articles that are on screen. Essentially, I know it'll say the objects as center box for all of these, but I'm looking into that as a bug right now, but on the actual outputted file that this creates, it is all correct. So essentially what happens is it has a designated object. So this would be like your axis box, battery box, center box. In some cases, this could be the top box, pitch motor, whatever part that we have included in here that has a series of measurable components. The node number is essentially the game engine, kind of the the bookkeeping for the game engine, knowing, hey, this center box node for measurement, this is like the 23rd node. We can change a bunch of things here. So all of the things that you see in these toggles or these white kind of text boxes are all essentially editable areas for each of those measurement points. So you can change voltage levels. You can change whether or not they're from a DC circuit or an AC circuit. If it's from an AC circuit, you can designate a phase number. You can designate whether or not it's a single phase or a three-phase system. You can designate whether or not, if it's an AC system, if it's a neutral. You can designate whether or not it's disconnected from the circuit. And all of those things are kind of inputs that get fed into the digital multimeter. And then ultimately that'll decide what the digital multimeter will spit out. And that's something that I could probably spend like a whole nother half hour giving a separate webinar talking about how that happens in the background of the simulator. But just essentially know that the multimeter in the background is smart enough to know, hey, I'm measuring a three-phase system to a neutral. I'll do the line to neutral calculation for you. Or, you know, I'm doing a three-phase line-to-line voltage measurement. All right, then that means I'm going to do this calculation. Or if I'm in DC, I can just take a normal measurement from ground, essentially, doing normal DC circuit analysis. Or if we're measuring, if we accidentally measure across a DC AC circuit together, it'll give you some obvious errors on the multimeter and so on and so forth. But all of those things are customizable here. And this is all just in reference to areas that were built out for other scenarios or potential scenarios for the simulator as it is right now. So the last thing that's there, you can see there's a bubble there for receives input from. And this is actually something that has been kind of input into the system but hasn't been utilized very much yet. Is the ability for nodes to basically receive input from other nodes. Currently right now, if we break a circuit, if we disconnect a point from the circuit, it'll propagate throughout the circuit. So if there are any nodes that are directly attached down the line from that node, it will know this is also disconnected from the circuit, and it will keep that in mind for whenever the digital multimeter does calculations. But eventually we want to be able to expand that to also work with power soaks or power leaks and be able to have that kind of affect a broader system. But anyway, you can go through and do this for just about every measurable node for anything that we've built out. And you can still look through the schematics here in real time to find out if these are the points that you want to change. Once it's done, you can basically designate a name for it. You could save out a file. The file will also be contained in the same directory as the executable file. And then if you went in to load the custom scenario, it will basically it'll show you a list of all the files in that directory. So that's essentially how it works. So I showed it one more time here, but you have the option to also potentially upload this to a server. That feature has not been fully implemented because we do not have a for sure place to store those on the web yet. But the idea behind that is being able to share these scenarios, these custom edited scenarios across either multiple campuses, multiple professors or instructors using it can use the same scenario if they're all uploaded to some central location. Or if you need to distribute it to students that are using this remotely, that's also another option to do it. So just kind of fast forwarding a little bit. So now I'll kind of show a little bit of a few clips here, and this is kind of winding towards the end of the show here of what the features are before I kind of do a recap of it. So this is the directory that we would have. So this is the directory that we would have at the end of our playthrough or what I showed for the demonstrations here. Some of these you might not see right away after downloading. A lot of these, if they don't exist, they'll be generated when they're needed by the software itself. So there's a folder here for reports. There's a folder here called custom. That's where it'll save the custom scenarios to. So the reports basically create text files. We can see the user submitted name, what the problem was, what the solution should be, and then what their report or what the actual problem, actual solution that's hard-coded into the software is. And if they have notes, you can see that there's a field down below where the notes would be kept, and then you can use that for more information. Here is basically an Excel file for the custom scenario that has all the information for the custom scenario. So all of the locations throughout the whole thing are all basically listed in a line format that when you load the custom scenario, it will go through every single node and load in every discrete value for the node information that it can feed into the digital multimeter. And on the far right, one additional step that I did here is for people that are trying to directly edit the Excel file instead of using the graphic user interface in the software, you can do that. I also have made it so that the description location as it would be seen on the schematics is actually listed there. The actual node location here that's on the left is not useful for identifying what place this is on the actual component. This would be much better if, in fact, these labelings are basically taken directly from the schematics that are included in the software. So if you have those schematics up or making some notes of what you want to change, then you can directly find that here and make those changes. So a lot of this will contain all of the information that we saw before. If we make some changes to some of that information, it should show directly here. So if we decided this one component for some reason is drawing almost no current but has a ridiculously high amount of voltage, you could pop that in there and it will show up whatever you inputted on the graphic user interface there as well, and it should propagate through if you load the custom scenario. The last things that I'll show, and I'll back it up just a little bit so you can see it one more time. When you're done with that, so I'd close it. So inside of the data folder are some more sensitive components that I do not suggest users generally interact with, but they're there. And those would be a player preferences file. Oop, I just accidentally skipped through this video. Okay, so the player preferences file. So when we open that, took a second, I had to double click it again. So this is actually a file where it keeps track of the learning module progress. This is actually scalable. So essentially I can create new areas. So right now we see that there's one called safety topics. And these have the 4 areas that we shown under the safety topics that are available as kind of the e-learning modules in there already. It actually keeps track with Boolean values, 0s and 1s, whether or not they've been passed. And you can actually edit this directly and you'll see the changes in the software when you open it the next time. But other than that, this also is procedurally generated by the software as needed. So if it doesn't exist already, or if it's in the wrong location, the software will recreate it itself and it will go through the process of doing all of that for you. And then the last thing that we'll see after this is something that's relatively new. So this is something that I don't think Tom has seen yet. So the last thing that we're adding in, and this is kind of a new feature for the customization of the software, is essentially trying to build in a system that allows you to interact with certain text boxes. So essentially what we're doing now, and this is fairly recent for the software, is making it so that, as you saw when the SCADA popped up, it had some very specific information about the pitch control system there. But we know that for every single problem, what's going to happen at that SCADA point is going to be different. So what we're doing is actually making it so that we can make a scenario by scenario context for what should be in that text box. And then eventually those will be editable by users from any place that has the software, making it so that you can see exactly what you want in the software when you run those things. We're in the middle of making it so that these are also procedurally generated for every scenario, including the custom scenarios. And that way we can make it so that the custom scenarios can have special readouts in the SCADA system interaction. And across the board, if there are any other specific points that we might need to change, so that it reflects accurately what needs to be said or shown for that particular issue. And this works on the same kind of format where we can designate keywords and then basically content that would be ended with some kind of parser. So that's pretty much the end of what I have to show, though. That's kind of maybe a little bit more of a deep dive on just the software in general, a lot of the customization components that are built into it. And just in general, like if you were to use it, what would you expect to see, that type of thing. So in the actual PowerPoint here, I have some notes about the node-based measuring system. So the reference system, and this is kind of just alluding to an abridged version of some of the stuff from the video. And then the custom editor and some of the things that you can see and how it reflects in the actual software. And then just in general, some of the upcoming changes. You may have seen some coming soon parts in the video. Those are some current in development modules that we're trying to integrate into any existing current changes that we're making. So that would include, we're currently in the middle of designing and figuring out how to do kind of an interactive schematics learning module alongside the safety learning modules. And doing more flushing out of some of the nacelle components for measurement like we did with the hub, starting with the top box, and we'll be moving to places like the slip ring and some of the other components that are around that area as well. But yeah, that's pretty much all I have. So Jack, would you like to take over?
Yeah, so we just have, I know we want to get to questions and answers really quickly. 3 more things that we want to talk about. So one, we want to leave some time for comments from Steve and Tom, who have some experience using this in their classroom. Kyle, go ahead and let's do the acknowledgements first before we do that.
Mm-hmm.
And so we just want to acknowledge all the different funding agencies that have helped us continue to push this forward over time: Department of Education, NSF, all the various collaborators and contributors. And then go ahead to the next one, Kyle. Of course, CREATE, of course, Ken and his group as well. If anybody wants to reach out and contact us, this is the email to jot down, just civs@pnw.edu. If you shoot us an email, we're still developing, and the project still has some more life in it for the funded period, but we're happy to share what we have so far, and we want to get that feedback. So just send us an email at civs@pnw.edu. All right, and so now,
thanks, Jack. We've had several people in the chat menu send me messages asking exactly this question. So you addressed the most important one. And the other question we've been getting is about how people have used this in the classroom. So maybe that's a good sort of segue to I know Steve and Tom are both on the call today.
Maybe Tom, let's maybe start with you. Do you have any comments?
Sure. It's when we teach all of the different pieces and parts, sometimes a student has a hard time seeing how that would all work together. And one thing that the simulator allows us to do is to kind of step them through the process, and then you can pause at each point and relate it back to that piece or that part that they learned maybe a couple of weeks earlier. And we found it's very successfully able to create a thought process so that because we actually do take care of turbines, we're out in the field working on multi-megawatt machines, but by the time they get to the field, they feel like they've already worked with the controller, using the SCADA, turning on and off pumps and motors, actuating things, and it starts to become fairly easy for them. You put a schematic next to that screen remotely, and they can really start to relate the wiring diagram to what they see happening in the SCADA system. And usually they'll come down to the 1 or 2 tests that they'll need to make when they're up tower.
Awesome. Thank you, Tom. Steve, do you have any words you want to say?
Well, just quickly, that in the classroom at Riverland Community College, we've utilized it, of course, from a training platform with a big focus on safety and troubleshooting. You know, troubleshooting is one of the probably the most difficult items to teach in the classroom. And I also work with EDF renewables, and so not only do I work with the classroom, but I also work doing continuing education for the actual wind industry. And there, you know, we have to realize that, you know, today there's a big focus on being considered qualified. And qualified, you know, really focuses on training, but it focuses heavily on hands-on. And you just don't have the ability to bring someone in and let them start doing actual hands-on on this energized equipment or interrelating with an operational turbine. And so by being able to go through the virtual reality trainer here that Purdue has put together, we were able to actually start, you might say, the first stage of that hands-on training. And that's the key part today. A big key part of being qualified is you have to be able to show, I mean, any way you look at it, that you have the necessary training and you're able to show that you've got those skills. So, you know, I mean, that's all part and parcel of what that all means about being qualified. It's, you know, the training is important, but you've got to be able to demonstrate the skills. And it's so much safer and easier here from a training standpoint to do that first on these trainers.
Great, thank you, Steve. Ken, did we have any other questions you want to?
Well, not so much questions, but a couple comments that came across, and I think it kind of echoes what Tom and Steve said. It's just that tools like this are really valuable because the time available to spend in the field, in the nacelle is so limited that being able to do a lot of this stuff virtually allows you to make better, more productive use of the actual time when you do have access to big equipment.
Yeah.
A few people in the chat menu were commenting about that, and I think that just really speaks to the value of your guys' project. And maybe the one other question that did come across here was what are your guys' plans for the future? Do you see yourselves continuing this work after this grant project? Do you have more things in the queue that you're planning? Anything you can tell us about?
Sure, yeah, absolutely. So for this current funding, we have going on for another year, and so we'll be wrapping around this time next year. We definitely were interested in continuing this project forward as well. The exact form of that, we're not sure yet if we try to go after additional funding or we try to make it self-sustainable by that point. Definitely that's the long-term goal, is that way the project will keep on going beyond just the funding period. We also have other related projects in the works. We're working with various industries. We're located, yes, we have wind nearby. We do a lot of work with steel mills and other industries as well. I mentioned the collaboration with NIPSCO, building out their simulators, but really applying this to just technician training in general in various areas. So it's not just limited to one particular type of system. And definitely, if anybody's interested in collaborating in ways to continue this forward, please reach out to us at that email, listed us at PNW, and happy to keep on talking.
Well, I think we're just about out of time here today. So there are a couple other questions out there, but I'll let them contact you guys offline to ask those directly because they're kind of specific. But let me just say thank you to all of you gentlemen for presenting today. Really exciting webinar. I'm looking forward to using it with some of our own students here at Madison College, and I'm sure several of the other folks on the call are as well. For everybody else that joined us today, or for people that are viewing this remotely as a recording, we hope that you all stay healthy and join us for future webinar events on behalf of the Create Energy Center.
Thanks so much, Ken. Again, really appreciate this invite, and thank you for everybody that's contributed, and looking forward to continuing to do more. Thanks so much.
Have a good weekend, everyone.
You too.